This is going to be a video that gives us an introduction on the scopes that are commonly found in our lab. Our particular scope is a DSO X 2012A. This will be similar to any 2000 series that the Agilent or Keysight makes. We're going to first talk about how we get our signal. So I have my probe here, and I am going to just push this, and I have a little loop, and I'm going to hook this up. I'm actually getting this signal here from the wave gen of the scope itself. In our lab, we'll often use the function generators, but either of them will serve us well. So we can see here that we have a sine wave coming in. Our probes that we use have an input resistance of 1 mega ohm, and they actually have a 10-to-1 ratio, which is why you see a 10-to-1 here. If you're ever in the lab doing something and your measurements seem off, just double check right here in this menu that you see a 10-to-1. If you need to change that ratio, it's found within this channel menu. You would hit the button, and then you can see probe here, and then over here you can see there's a 10-to-1, and you can adjust that. Sometimes someone that was in the lab before you might have been using the scope for a different purpose. Another thing that's helpful to know on this menu for the channel, if I hit this channel 1 and I get this menu, I can see over here this says coupling DC, and I can push that and I can change that to AC, and when I do that now I see AC on this channel, or I can turn it back to DC. What that simply means is if I have DC coupling, I'm allowing AC and DC into my signal. If I only wanted AC and I wanted to block the DC, then I could select AC coupling. The default for our scopes is DC coupling. So now that we're looking at our signal, if we want to adjust, our y-axis is our volts, our amplitude, and our x-axis is time. I can come here and I can adjust my scale. I can zoom in and zoom out. I can also adjust my position. This can be helpful. Ours is a sine wave, it's not that different, but sometimes we're looking at something and we might want to see what's happening before or after a certain event. Likewise, down here is my vertical menu, and I can adjust my vertical scale, I can adjust my vertical position, and when I have 2 channels input, then I have the controls for channel 2 right there, and I can also adjust the position and the menu and all the things in the same way. A really important thing to understand on these scopes is the concept of triggering. When I set a trigger, I'm telling the scope what I want to look at. The scope is always measuring and buffering measurements and then displaying what we are telling it to. Over here, you'll see a little yellow T and a little triangle, and that is telling the scope, show me what's happening when right now we're set up. If I hit this trigger menu, it's saying I have a trigger type edge. It's a falling edge. You can do a falling edge, a rising edge, a lot of different things, and you can tell the scope exactly what you want to look at. This isn't quite as meaningful for a sine wave, but there are times where you can specify a certain thing that you want to see, or you can even put in an external trigger and do complicated things. It's a really useful tool. So right now you can see the trigger is there. So I can come over here, right here, this is my trigger level. And if you see, if I come above my trigger level, the scope is still saving information and displaying information, but it doesn't freeze the wave in quite that same way. And so the trigger is what kind of takes that picture and says, show me this. And you can see that as you move your trigger along, it changes the horizontal placement because of that trigger. And now I just push the button and that sets the trigger to the center. The other thing that's helpful to know is sometimes you might have a noisy input and you're not able to have a good standing frozen wave, and you can come over here up on this run control. It's hard to see the text on this button because it's illuminated, but this reads run stop, and you can hit that button and freeze your signal and just see what's there, and then push it again when you want it to go. Another helpful thing about the trigger is if you are having an event that happens occasionally, you can hit the single button and the trigger will display just one of those events and freeze it. So for what we're doing right now with this sine wave, our run stop and our single look similar, but a single can be a helpful tool if you just want to see something that happens occasionally. Another thing that's important to note about the trigger is if I had an input signal on my channel 1 and also my channel 2, the trigger will default on channel 1. It's possible to go in and change that on this trigger menu when I push trigger, and I can select source and I can trigger off my channel 2. But then every time I would hit my auto scale, the default would change back to 1. So if you're having two inputs and one is clearer and stronger than the other, it's best to choose that input for channel 1. So let's now make our signal. You can see that if I'd hooked something up and my signal wasn't displayed just how I want it to on the screen, I can come over here and I can select this button. It's auto scale, and auto scale will give us the scope's best guess of what we're trying to see. And if we are looking at a fairly clean sine wave, then Autoscale does that beautifully. It can tell us what we want to see. There are times with Autoscale where it might zoom in on something that isn't what you want to see, and you could simply zoom out or in horizontally and vertically as needed. But the Autoscale tends to be a powerful tool for us. So now that we have this sine wave, let's look at what we are actually looking at. If we come over here in this measure section, we can click this measure button, and again these buttons all change the menus at the bottom. So I will click measure, and I can see source 1, which is the channel I want to measure. Here, if I push this button, it will give me a lot of different types, and I can come over to this knob and choose what type I want. So let's start out with frequency, and I'll push the button and I'll have frequency. The other measurement that's already in right now is peak to peak. But in these types, I could have period or any number. I could have a maximum voltage, a minimum voltage. There's just a lot of different measurements you can take here with that measure menu. If my signal were not as clean as this, if it had a lot of dimension here with noise, I can come here under the measure and I can hit cursors. Cursors are fabulous because you can push this button and it will bring up options. Over down here it will tell you which source you're doing your cursors on, and you can also get that menu here, but I prefer to come over here to this knob. It's very easy, and I could say I'm going to put Y2 at the top of my signal, and I'll actually put this up a little bit so we can really get a great measurement. So here's Y2, actually Y1, and it says about 724 millivolts. Now I can come down here for Y2, and I can see up here that's at about minus 753 millivolts. Down here it'll tell me a delta Y. So my delta Y right now is 1.48, so I'm about at 1.5 volts. And for a comparison now, I can look back at my measurements and I can see my measurements peak to peak set about 1.5, 1.52. So those are showing pretty close together. And again, the cursors can just be valuable if you have a noisy signal and you're not sure. Another great way to deal with noise is I can hit this button. This says acquire, and this is going to affect how the oscilloscope is dealing with the information. So under here, the default is acquire mode normal. I can come here to peak detect, and peak detect will give me my highest and lowest. It'll show me what the biggest and smallest values are, which for us right now it's pretty clean, so it looks pretty similar. And then on averaging, it will clean up a very noisy signal because it's taking the average of all the inputs that it's receiving. So this has been just an introduction for our 2000 series Agilent DSO. We went over briefly the horizontal section, the vertical section. We've got our auto scale, which is a great tool, our run stop, which can freeze things for us, the cursors that we can make manual measurements for both X and Y direction, our measure menu, our trigger menu, and then our channel menus that we can use to change our probe values or our AC/DC coupling. Thanks for watching.